Yeah, my name's Jamie. I'm an Android developer at Pulselive. Today I'm going to talk about IntSnaps. Talk about dynamic features as well, because that's what IntSnaps fall under nowadays, but mostly sort of IntSnaps focused. So last year we built the Cricket World Cup 2019 application. It had everything you sort of expect from a sports app. It has a news, video, live scores. But the interesting thing I want to talk about today is the quiz feature. So at the end of every day, the ICC would post a quiz so that users go and play. The quiz would be about that day's play. And the users could go through, play the quiz, and then share the result with their friend. It was a very, very nice, simple, self-contained feature that had a very sort of like simple user journey that made it sort of ideal for an IntSnap because it could live separately on its own. So if you're not too familiar with IntSnaps, you can actually try IntSnap now. So if you Google search now, if you want to, for Cricket World Cup quizzes, subject to Google search indexing if it decides to play nice. Or if it doesn't work, you can go find the ICC app on the Play Store. Hit try now. The quiz feature as an IntSnap was our final product. That's not actually the interesting thing about what we did. The Cricket World Cup app has been an app since the 2015 Cricket World Cup. So we've got 4 years of legacy code to deal with. So it turned out to be very, very difficult to take a 4-year-old code base that was quite monolithic and turn it into something we would publish an IntSnap. So today I'm sort of going to go through our sort of journey and try and cover as many of the problems we hit and show how we solve them for Cricket World Cup. So it wouldn't be an IntSnap talk if we didn't talk about dynamic features. So just so I can get a sense of the room. Can I get a hands up if you know what dynamic features are? Models. Okay. Keep your hands up if you've ever played around with dynamic features before, if you've used them in a side project. Anyone use them in production? Hands up. Those guys don't count. Okay, so I'm just going to give a very brief introduction to dynamic features because it is kind of key knowledge needed before we get into the real nitty-gritty of stuff. So what are dynamic features? They're a new type of Gradle module that sort of gives you complete control over when a feature is installed. They come with 4 different flavors. So you can have an at-install time feature. This means that we're going to download this feature when the user installs my app from the Play Store. This is the same as how you'd conventionally deliver an app, no difference. Conditional delivery, so download this feature when the user installs my app, like before, but make it so it's subject to a few conditions. So say you have a feature that uses camera 2, and you only want to install that feature on devices that have like support camera 2, so lollipop devices. You can set conditional delivery, which means any users that don't support that feature won't install the feature at all, which is quite nice, saves some download space. Instant-enabled features, this is the one we're going to focus on today. So let's download this feature and just this feature now. Don't worry about the rest of the app. And the final one is on-demand delivery. So we're not going to download this feature now when the user is installing my app. I'm going to download it later when the user actually wants to use it. This is a super powerful system, and you keep your initial app download size very, very small by avoiding downloading features these are people are not going to use or other ones they can't use. But the one we're going to focus today is the instant-enabled dynamic features, which are sort of the kind of new name for IntSnaps. So that is like an overview of what dynamic features are, but how does it actually look on an Android project? So your Android project may look something like this. You may have a sort of like clean arc layer set up with your modules, your app data domain. If you're looking to modularize a feature here, you may move it into another Android library module. But the bottom line is that the app module is the top level module, and everything gets merged into one artifact at the end, the application module. Dynamic features sort of flip that around, and dynamic features depend on the application module. So this enables dynamic features to not be downloaded at install time, because the application can now run without a dynamic feature, because it has no idea it exists, right? At this point, the application has no idea that the quiz feature exists. So we can sort of like add and remove that quiz feature, and the application works just fine. Unfortunately, Android has been around for 10 years, and for 10 years it's assumed that the application module is going to be the top level module. So it's introduced a few oddities, a lot of which I'm going to talk about today. So let's go back to the sort of the clean up modular setup. This is where we started. We're modularized by layer, but the problem was that we still had 4 years worth of features in the app module. The app was very sort of monolithic, it was huge, every feature was in there. We'd even built our quiz feature by this point, and it was in the app module. So we could try and instant enable this app module. All an IntSnap is just a very small app at the end of the day. So you could try and enable this and upload it to the Play Store as an instant app. It won't let you because it's not smaller than 4 megabytes. We've got 4 years worth of features in there. It was like 56 megabytes, not 4 megabytes. So yeah, you could instant enable an app module. If you've got a very, very small app, you could just call it a day here, instant enable this app and ship it, no problem. If you have a real app, it's not going to be smaller than 4 megs. Unfortunately, we can't just move quiz to the dynamic feature either. When you install an instant app, you also install a base application. Instant apps like to give the idea that they're just this feature, but actually under the hood, you're still installing an application. That's how Android works. You have to have an application installed. So an instant app is just a very, very small app. So we could move the quiz out to its own module, into a dynamic feature module here. But at the end of the day, when the user goes to install the instant app, they still have to download the application module, which is far too big. So it won't fit the 4 megabytes again. So we can't do this either. So instead, what we did, we split app, and we brought app out into its own dynamic feature that was always installed at install time. We introduced a new module called base, and this is a much, much leaner, much smaller application module that could just contain the stuff we needed for the instant app. So we took only stuff we needed for the instant app from app into base. So when the user installs the app from the Play Store, it's no different to how it was before. They get everything. They get app, they get quiz, and they get the base application module. When they install the instant app, they cut out the app entirely. We just get quiz and base. This turned it from impossible to make an instant app to make it possible but very, very difficult. We still have to get below 4 meg, and that's still surprisingly difficult. So let's talk about the 4 megabyte limit a little bit more. In my opinion, this is actually the hardest problem to solve about releasing an instant app. 4 megabytes is not a lot of space at all. But I think the most helpful thing I can give you is to give you a breakdown of where all our 4 megabytes went. So the first thing is Android and Android X. That took about 1.2 meg of our 4 meg. The material design lib on top of that, 500 kilobytes. Firebase was nice, it's just 60 kilobytes, but it brings Google Play Services with it, so 750 kilobytes. Now finally we're getting to some actual stuff from our project. This is some Cricket World Cup assets. Unfortunately, Cricket World Cup is a heavy branded app, so we had 500 kilobytes of images and stuff we had to bring in. Fonts, TTF files are huge. Hopefully you can use downloadable fonts. We had a proprietary font, so we couldn't do that. So we actually include the TTF files in our download, 200 kilobytes. We're actually writing some code now, so another sort of networking data layer sort of stuff, another 500 kilobytes. Now finally we're writing stuff for our instant app for a combined code and assets of 250 kilobytes for a grand total of 3.95 megabytes, so we're 50 kilobytes under the limit. The things that you sort of kind of want to look at is these assets, this 500 kilobyte of assets. You really got to look at it if you can get rid of your PNGs, your WebPs, your SVGs. Can you offload it to an S3 bucket? Can you get rid of it altogether? We actually had, before we got under the 4 megabytes, we had about 300 kilobytes of font files. Then I found that the medium italic font was being used exactly one text view. So I was like, sorry designer, I need those 70 kilobytes, so I'm gonna need it back. So I got rid of that and changed to bold and no one noticed. So eventually, yeah, we got below the 4 megabytes limit. If I had to go any lower, I had to find somewhere else to find space. This sort of common ICC Cricket World Cup code that's taking up 500 kilobytes, where I'd look. If you think back to our clean art diagram, although we split out app and quiz, we're still bundling the entire data and the entire domain. So that includes all the networking and business logic for fetching, live scores, news, video that we don't need for the instant app. So thankfully we're under the 4 megabytes here, but if I need to save more space, that's where I'd look. The nice thing to note actually is if you want to publish to the internal trash track, it doesn't have to be under 4 megabytes. So to publish to production, you need to be under 4 megabytes. But if you want to demo to a client or your company what an instant app is, you can upload it to the internal trash track and there's no download limit. When I first demoed instant apps to Pulselive, our instant app was 12 megabytes. So yeah, we can just use the internal trash track to demo it and test it if you want to. But yeah, 4 megabytes for production. I sweat dependency injection, hot topic at the moment in the Android world. Hands up if you're using Dagger for your dependency injection. A lot of people, right? Keep your hands up if you're using Dagger Android. Don't be ashamed. we at this point were using Dagger Android as part of our project. We've sort of since moved away from it, you'll see in a minute. So this problem in particular will pop up if you're using Dagger Android or if your normal Dagger setup uses subcomponents, because Dagger Android is subcomponents under the hood. But this is a particular problem with the subcomponent structure of Dagger. So we go back to this Gradle diagram. We want to bring this base application module in, but that means we need to move the application class from where it was in app now down to base. This is what it looked like before we moved it. The problem might not look obvious at first glance. You have Timber and Fabric here. This is going to be useful in your instant app anyway, so this can come down to base, and you'll have no problems here. You're going to need it anyway. The problem actually lies with the Dagger Android stuff. If you think about how an app component works, it likes to know about literally everything. So if you want to bring your application class down, you have to bring your app component with it, and your app component knows about everything, so you've got to bring everything else with it. So we're back at square one where our application module is far too big. So off the back of that, we kind of realized we need to get rid of Dagger Android and the subcomponent structure. We had a sort of few discussions about it, came to a few conclusions. We don't want to redo the Dagger graph entirely in the app. We had like 70, 80 screens worth of app. We don't want to redo the entire Dagger graph and get rid of Dagger Android completely. Anything we could touch the app module as little as possible was a great solution. We realized that few dependencies actually need to be singletons. A few dependencies actually needed to be part of the app component and need to be scoped to the application. Most things were stateless, so we could don't actually need singletons too much. We don't need Dagger application either. If we need to inject into the application, which we're not at the moment, we can use that conventionally with Dagger. So this is what we proposed. The app component would stay in app, or try and touch it as little as possible. We'd move the application class to base, and we'd create a new core component that provided any singletons that we actually needed. The app component could depend on core component for those singletons. And the app component will be built and scoped to activities in app. This is the important change. Previously, the application was built in app component. Now it's just going to be the activities that are built can use the app component. Because most things didn't actually need to be singletons, this actually results in like no behavior changes in app. They don't know that they're now scoped to an activity rather than an application. So this worked very well. It's got like a visual diagram of how that works. So we've got a new core component that's in the base, scopes the application, contains anything that truly needs to be a singleton. We've got quiz component, which is now in the quiz dynamic feature, scopes an activity, depends on core component for those singletons, and the same in app. The app component is now being initialized by activities and not the application. I appreciate it's not that understandable from this, but I wrote a very, very long blog post with code samples and everything and how we exactly solved it. So if you are using Dagger Android and you want to build an instant app, then I'll hire you and checking it out. We based this core component structure off of the Plaid sample project. Plaid is a sample app from Google that sort of demonstrates how to use dynamic features. It's not an instant app project, but it's a dynamic features project. It's where we based sort of our goal Dagger setup to be, while trying to get as close to that as possible without disrupting app too much. So I'll mention Plaid a few times in this talk. Highly recommend checking it out. Another problem we face is Android manifest merging. So if you think conventionally about Android manifests, how they're merged, when you have library modules, all the manifests get merged, all your library modules up to your application module, and at the end you have one big, huge Android manifest. How does that work when you have something that depends on the application, not the other way around? Well, Android still wants you to have one manifest per app, which means your manifests now get merged down to the base application module. Again, it introduces some weird problems. This is a snippet from our dynamic feature. So here we're declaring the quiz activity in the dynamic feature module, and we've declared a theme. All this stuff lives in the dynamic feature. The problem is now that this manifest is going to get merged down to the application module, but this stuff doesn't exist at the application module, doesn't know about it, unlike the libraries where it would know about everything. So what happens now? You'd hope that the build system would be clever enough to deal with this. It would go, I know I don't know about it, but it's a dynamic feature, right? So I will know about it at some point. No. It's quite happy for you to declare activity that doesn't exist. Doesn't exist. You can actually try this in your own apps now. If you declare a random activity in your manifest that doesn't exist, and it should give you red squiggly lines, but they all compile. The problem is with the theme. The first compiler you'll get is the fact that the theme doesn't exist. We know it does, but the compiler can't find it. This is annoying. There are a few ways around it. You could just move all your styles to base. It's a bit inelegant, but yeah, it's going to break all your separations of concern. You now got stuff. You'd ideally keep all your styles and themes with the dynamic feature that's part of. But I mean, if you've got to make it work, you've got to make it work. Also, if you're bringing styles down to base, you may be bringing fonts down as well, or drawables and stuff that's going to sort of start impacting your 4 megabyte download limit. If you don't need it for your instant app, you don't want it in your base. There is another solution, again, comes from Plaid. You can create some stub styles in your base module. So in your base Gradle module, you can create this completely empty style, just name it the same thing. And then in your dynamic feature, you can actually override it and give it override it with the theme material components, give it the colors and stuff. Again, this all comes from Plaid that I've stolen it from, but so effectively what happens here is that the compiler is now happy. It can find a style called quiz theme. It's empty, but it can find it. But at compile time runtime, actually what gets used is your real theme. Apart from when it isn't. For this like stub theme thing to work, you have to be shipping as an app bundle. For some reason, when you build as a universal APK, it will use the empty stub style, so all your stuff's going to be broken. It won't use the overridden style. That might be okay, you might think, because we ship to Google Play using app bundles, so we'll be fine. For us, it was annoying, because although we were shipping to Google Play as an app bundle, we were giving test builds to QA as APKs, so all those are broken. And there's no split install support on pre-Lollipop, so although you shipped to Google Play as an app bundle, when the user installs that on a KitKat device, actually what they get is a universal SDK, and it breaks because you got the wrong style. So what we end up doing, we just move our styles to base. It's unfortunate, really. I've got no better solution for you. If those 3 things don't apply to you, then you're in luck. For Plaid, it's a sample app, and it's app bundles, and it's min-SDK21, so they were fine. On a real application, it wasn't fine for us. You'll get once you start using dynamic features, you'll get the temptation to try and make every feature a dynamic feature. I'm going to tell you now to try and resist that urge, because it has impacts on your 4 megabyte limit. So here's another example. You may have, I've introduced another dynamic feature here called videos. And let's say that you support Chromecasting in your app. So you may have the Play Services cast dependency in videos, but you may want to show the cast button in the rest of your app as well. So you need the Play Services cast dependency in both videos and app. The problem is that when you include a dependency in more than one dynamic feature, it has to come into base. You get a compiler error saying to avoid runtime errors, you need to decouple these common dependencies into base. And not used any of the Google Play Services libraries will know they're quite big. So although Quiz needs to know nothing about Chromecasts, all of a sudden it's getting the cast dependency and it's impacting our 4 meg limit. So you get the temptation to dynamic feature everything, all of your features, but avoid it. Only make dynamic features what you need to be dynamic features. There are in the upcoming Android Gradle plugin 4.0, you will be able to make dynamic features dependencies of other dynamic features. And this sort of avoids this issue because you just need to have one strand of dynamic feature modules having this dependency. So here to solve that, you'd make videos a dependency of app, and it'd be fine, it would be happy with that. But for now, yeah, any common dependencies across 2 or more dynamic features have to be included in all of them. It's a shame. I'm going to finish with some quick fire tips. Some of these should be obvious, but worth mentioning because they tripped us up as well. So double check your protocol rules. This one sounds so obvious, but we were sort of like 60, 70 kilobytes above the 4 megabyte limit we're trying to get to. And we found a ProGuard rule that was keeping just a little bit too much. It's one you don't check your program tools often, but you may find there's one sort of like slightly rule that's keeping too much. So double check your program rules, make sure it's only keeping what it needs to keep. Use Android Gradle plugin 3.5 or higher. We say this because when we built it, 3.4 was stable and 3.5 was in beta, and there were a load of problems with 3.4 building in Android Studio with giant features. So use at least 3.5, which is stable now. If you run into any weird sort of build issues, it's worth trying on 3.6 and the 4.0 alpha. It might resolve it. And the last one is to use the APK analyzer. When you build your app bundles locally, the end output is a load of APKs, and it's really worth putting them all through the APK analyzer to see what's actually taking up space. It's worth always using the highest density bucket, so XXX HTTPI. We hit a point right near the end where our X HTTPI builds were below 4 megabytes, but XXX HTTPI was above 4 megabytes. To ship in production, you need to have everything under 4 megabytes. So when you're checking stuff and when you're testing the 4 megabyte limit, make sure you're using XXX HTTPI builds. Great. That's all my quickfire tips for you today. In terms of further reading, again, the played sample pipe is really, really good for demonstrating giant feature projects. There's a load of articles by Ben Weiss who goes over some of the reasoning behind some of the stuff in played. That's where I got the stub styles idea from. So 100% recommend that going out. And there's some Android docs there. On Medium, I've been trying to write out some sort of lengthy articles about all these problems. We covered sort of 4 or 5 today, but there are lots more that we came across. So I'm gradually going through and trying to write them all up, including the stuff you've seen today. So if you are trying to build an instant app out of an existing large project, then please go give us a read, because hopefully they're very, very useful. Thank you.